Hey, so welcome to the सिस्टम डिज़ाइन एंड आज मैं करने वाला हूँ CDN के बारे में बातें. So I wrote some topics at the top they will be and I will be discussing at the bottom, and maybe I'm using my notes sometimes or maybe not. Let's see how I remember all of it. Okay. Mm, okay. So first topic is define CDN, right? So CDN is content delivery network, and content delivery network means on the request of user, the net okay content delivery network. It is a set of servers, networking servers, those provides the response to the user client, and all those servers uh, provides, yeah, that is the CDN. And CDN is content delivery network, and how it works generally. So small, if you see a small architecture of it, that is look like this. So here you have a client. Okay, this is the computer of the client. It sends the request, and then request reach to edge server, and then there are a lot of edge servers there. Okay, yeah, and it reaches the nearest edge server. If the data is present in the edge server, then it will send that request to the request response to the user, else it won't. And if it is don't have, then it will go to the origin server that have the actual data, or the source of truth is that it get or fetch the data from the origin server, cache it inside it, and respond to the user. So what is the CDN in whole thing? CDN is a set of network. It is a network of servers which are intentionally placed geographically, so the latency can be reduced for the user requests. Yeah, that is the CDN. And what is the POP? Suppose here you have a, let's talk about India. So you have a Delhi. Let's make a map of India first. I'm not sure how good I am. Okay, let's remove this. It's it's look like India, most of it. So suppose here we have a Bangalore, here we have Mumbai, here we have Guwahati, here we have Delhi, have Kashmir. So these are the geographies. At each of them, we have our what we will do. We post, because suppose there is a one user here. If this user is trying to request, and our origin server is present here, suppose it is there, right? And if that is want to request, then the distance between origin server and user is quite vast. So the major data like videos, photos, statics, static data like JavaScript, CSS files, images, all those need to be sent from this location, and it will be the time consuming. So reduce the latency. We push some of the nodes, like at every location we put a node, like Guwahati pe G1, Bangalore pe B1, M1, D1, K1, and it cached the data from the origin, and then user can directly request from M1, and now based on the request, if the data is present at M1, it will send to the U1, else it will get it from the other nodes, or maybe from the origin. So the location of the edge server in the CDN is called as POP, point of presence. And the edge servers are the servers those caches the uh, cache the data inside it, but they are not the source of truth. If they don't have the data, they get that data from the origin. And the origin server is the source of truth from where actual web application is running and data is stored there. So this have the actual, these have only the caching. Okay, these have caching, these have actual data. So now we know the edge server. So what are the things are done? So CDN done, POP done, edge server done, origin server done, cache warming. So cache warming. Suppose you have your this CDN network and somehow this M1 node is down. And what will happen? We will create a new M1 here, and this M1 will preload the data into it. We preload the data into it. If the user requests to it, it must have some data in it. So for preloading, the preloading of data into a edge node, that is called cache warming. Okay? Then TTL. TTL is the time to live actually. So if the data is there and data D1 is there and D1 got updated on the origin level, D1 updated, then this cache is not used, it is useless. Okay, so we set a time so until which this data can be used. That time is called as TTL. It is used to replace the data or invalidate the data. Yeah. Anycast. Anycast is a routing mechanism of inside this. Suppose there are a lot of edge servers there, and user made a request. How this request will reach to the nearest edge server or any of the edge server so it can get the response. Okay, now we got that. Now next one is the Anycast is done. That is the and then content invalidation. Content invalidation is the marking a content or data in a node, marking a content or data in a node as a invalid. That is called the content invalidation on the change if any change happened to that particular data. Okay. Then cache purging. Cache purging is deletion of the cache from the edge server is called cache purging. Okay, let's see. For this first line of questions, did I did good or not? I'm looking into it. So CDN is a content delivery network in a distributed network. Is a distributed network of servers strategically located across the various graphical locations to deliver web content such as say, static and so similarly we did origin server, edge servers there are, user is there, and terminology point of presence. Okay, location of the edge server, physical location where CDN servers are deployed. POP is strictly placed crucial. Okay, it's not about the edge server, it's about the all the servers. It can be origin server that those called as the POP presence of point of presence. Edge server is an edge server CDN located at the POP responsible for caching and delivering content to the end user. Origin server, the origin server is the primary server where original content cache farming process of preloading content to the server. Correct. Time to live is the value set by the origin server that determine how long a piece of content should be stored in the. Anycast is the networking routing technique used to CDN redirect the request. Content invalidation, cache purging, cache control headers. Yeah, Cache control headers and CDN prefetching. CDN prefetching is again before users request, if the data is fetched by the edge server, that is called CDN prefetch. CDN prefetch preactively loads and cache content before the user requests it, right? Okay, I think these two things are not there. Let me add them. Command. Okay, first thing is this. Oh, that's why it is not happening now. CDN prefetching. Okay, these two things are added. Now let's move to the next part. Okay, next section is benefit of CDNs. What are the benefits of CDN? First of all, uh, reduce the latency, right? First of all, let's make that same diagram again so I can discuss this. This is the India, Guwahati, Bangalore, Rameshwaram, Mumbai, Goa, Delhi, and mm, Varanasi. And here we have the user one. So benefit of user, and here suppose we have our origin server. So it reduce the latency. First of all, definitely reduce the latency. Okay, latency. It reduce the latency, improves the performance. How it improves the performance? Um, Okay, so content delivery network improves the performance by because suppose you have a website that have some dynamic data and some static data, then you can move that static data to these caching servers, and the dynamic data you can done on the fly by using your origin server, and then your origin servers performance will increase automatically because it is not handling the static data at all. And in another way, if your whole website is static, in that case also performance is going to be increased because now edge servers will be taking all the requests instead of origin, so that's why. And performance scalability. So for distributed systems, scalability got improved because now all these servers are uh, um, scalable, because if there is traffic increase happen or something happens, in that case this we can introduce one more edge servers to it, so that it makes it more scalable in a way. So latency got reduced, performance improvement happens, scalability got increased, or and yeah, fault tolerance. It isn't fault tolerance at all because it introduced the fault tolerance in the system, but it reduced the DDoS attack, denial of service attack. How it do? Because you having these edge servers, if there is a lot of requests are coming from a single place for as per the DDoS attack, then that particular edge node going to be uh, fail. But overall, in that particular reason, it will going to fail. But overall, other edge servers will still be up and running, and it will help us to recognize like which why it is happening actually. So reduce security vulnerabilities like DDoS, and then you can introduce WAF firewall, FAF, FAF, firewall, okay, firewall, WAF, okay, wall of fire, ठीक है, whatever firewall है, ठीक है. So entry points you can set for each of the location if they are location based. Hmm. And yeah, those are the benefit. Let's see. And one more thing, let's discuss about the origin server versus edge server. Okay, origin server. Origin server is the source of truth, source of truth, right? And then source of truth है origin server. First thing, second thing, origin server will have uh, okay, edge server fall back to the origin server. True. If you are talking about the origin edge server, then edge server caches the data and also um take the request from the user and respond to them. And yeah, so both of them are completely different. CDN routing request handling. CDN routing request handling. Okay, CDN routing request handling. So if there are multiple nodes, edge servers and the origin servers, then how this routing happen from when the request is coming from the user? Let me remove, clean it a bit. Okay, so here you have a node, here you have a node, here you have a edge node. All of them are edge node. And now if u2 is requesting, making a request, some kind of request, then suppose starting में ये जाता है node पे and routing, and it depend on how many nodes it is connected. Is it connected to the origin? Is it connected to the D? Is it connected to the G? How many places it is connected? And then it will decide where to go based on the routing algorithm. Okay, routing methods you might say. So how many routing methods are there? So okay, based on the topology, it will decide the routing methods. Okay, CDN routing handling. So first of all is Anycast routing. So Anycast routing. Anycast routing don't look at anything. Is it just check whatever it send the request, and whichever edge server taking the uh, minimum latency, it count the latency by the number of hops, and it's sent to that only. Suppose here is this one and this one. So if this one takes the less hops, then it will send the request here. If it takes this one, then that is the Anycast. Then we comes to the CDN. Okay, DNS, DNS routing. So DNS routing uses some other many parameters. Based on them, it select the routing. It can be the bandwidth, it can be the latency, it can be the geography, or many more, right? And then we have GeoIP location. It actually send the request to the nearest edge server, physically less distant server. It doesn't look for anything else. Okay. Then we come to the CDN network topology. Topology is means ki how these edge nodes and edge servers are connected to each other. That is called topology. Means this node can be connected to this, or maybe it's just connected to origin and then take the request from user. There are multiple ways to do, and those are the we'll discuss in this topology. So there are multiple topology already. Let's discuss one of them. First one is, okay, again, let me make this diagram here. I don't know, I'm just getting worse at this. Here we have one node, okay, one edge, or here we have origin. So, flat topology says, flat topology says कि all the edge server directly connect to the origin, and these edge servers can take request directly. So that means this edge connected to this connected to this. This is the flat topology. If user is here and if user is here and if it is making request, it will goes to this and it will directly ask the origin if you don't have the cache. Okay, but if you have a large system, then this origin might be get overwhelmed by these much of the edge servers. In that case, we can have another topology that is called a hierarchical topology. In hierarchical topology, what happens? Uh, there are some edge nodes which are connected to origin like this, and the other edge nodes depend on these. Like this is connected to this is connected to this is connected to this is connected to this, and this is connected to this. Now, those whatever the edge servers, those are on the leaf, like this one, this one, this one, this one, or maybe all of them can take the request from the users, and yeah, U1, they can take the request from the U1, and then now this edge, okay, now in hierarchical topology, all the edge nodes do not depend on the origin to be cached. Some of them depend on the other edge nodes to be cached, so the load from the origin server is reduced. Okay, hierarchy. Then we have this mesh topology. In this mesh topology, what happens? Every node is connected to the other one. Okay, this is quite cumbersome. So this is connected to this is connected to this. So everyone is connected to the everyone. So yeah, it's a quite complex topology, but gives you the it gives you the fault tolerance, and then second one is inherent redundancy. Redundancy. Those are the major benefit of it, but it's quite complex. Then we have the hybrid topology. Those are the mixes of it, and this is how all of it is finished. Let's see how I did. Benefit of CDNs. So reduce latency, definitely. Ticked it. Improved performance, ticked it. Enhanced reliability and availability. Yeah, this thing is also a good thing. It improves the availability because with the multiple edge servers, different location CDNs can provide built-in redundancy and fault tolerance. If this one server become unavailable, request can be automatically. Yeah, scalability. CDNs can handle sudden traffic spikes and the volume concurrent. Security management. Yep. Web application firewalls, SSL termination, and DDoS protection. I only talked about the DDoS. Okay, cool. Doing good. Origin server versus edge server. So origin servers is centralized content storage and content का source है and performance limitations is there. Yeah, directly serving all the user from that, then it is not performant. Geographically distributed होते हैं. Edge servers content caching करते हैं. I talked about caching. Load balancing and scalability. Yeah, I didn't talk about it. Load balancing and scalability. Yes. Then example scenario. Yeah, this is okay. Then we have CDN routing. So CDN routing is the process of direct. Oh yeah, this thing I missed. CDN routing is the process of directing the user request to the most suitable edge server. Routing decisions are typically based on factors such as network latency, server load, and the user's geographical location. Latency, server load, and the geographical latency. सबसे पहले आती है Anycast based on the latency and count the hops. The network latency and the hops based on it send the request to the in Anycast, multiple edge servers shared a single IP. When a user send a request to that IP address, the network routing system directs the request to the nearest edge server based on the network latency of the. Okay, cool. Then we have the DNS based routing. So with the DNS based routing, when a user request content, the CDN's DNS server respond with the IP address of the most suitable edge server. This approach can take into account factors such as geographical proximity. Yeah, definitely. Proximity, server load. Okay, it's geographical proximity, server load to select the best edge. Then GeoIP only takes the nearest edge server in the term of geographical distance only. Then we come to the CDN caching strategies, how you can make the cache them. Okay, I didn't discuss it. That's okay. CDN network topology. Network topology describes the structure and organization of CDN's distributed network. Distribution and network. Structure and organization of CDN distributed network. Different topology can be employed to optimize content delivery based on the factors of performance, reliability, and cost. Flat topology. We already all edge servers in the CDNs are directly connected to the origin. Hierarchical topology. In hierarchical topology, edge servers are organized into the multiple tiers, and with each tier being responsible for serving content to the tier below it. Can improve scalability and distributed load among the. Then mesh. In mesh topology, edge servers are interconnected, allowing them to share content and load with each other. This approach can enhance redundancy and fault tolerance. Then hybrid is the hybrid combine of any of the values that you want. Oh, then we come to the push and pull CDNs. Push pull CDN. Okay, what is the push pull CDN? So, suppose there we have a edge server, here we have the origin server. Okay, sorry, I'm not sharing this correct screen. Okay, suppose this is the origin server. This is sorry, this is edge server, and this is the origin server. Now, if the caching is pushed to the edge server, data is pushed to the edge server, that is called as push CDN. If the data is pulled by the edge server from this origin, that is called the pull pull CDN. Okay, so pull CDNs are used. Now I'm confused a bit. So what are the benefit of them and what are the drawbacks? Okay, so yeah, so for pull CDN, yeah, now I know. For pull CDN, this origin should be live always. always live, because we don't know when edge server going to ask the data from the origin, when it will going to ask. But if it is a push CDN, then it don't depend on, like, it don't uh, n- it will automatically push the correct data to the edge server, and origin server node need to be always live. So these are the two things I only know, but let's see. There are a lot of things I think. In a pull CDN, the content is not stored in CDN server by default. Oh, okay. In pull CDN, the content is not stored in CDN server by default. Instead, the CDN pulls the content from the origin server when the user request is for the first time, once the content is cached. Okay. But in push the CDN server by content provider, usually through manual upload or automated processes. So these are complex. Okay. Advantage, better control. Content is readily available, but more complex, because maintenance more complex to set up and maintain, increase storage cost and responsibilities. That's why. Okay, cool. So this is done for now. Thank you.